Welcome to Show's classes. Today we are going to be dealing with some important questions on physics. You can call or WhatsApp at the number given on the screen for any doubts or full videos on our courses. Let's begin with our first question. The first question that we have is that maximum torque acting on the electric dipole of moment 3 into 10 to the power minus 29 centimeters in a uniform electric field E is 6 into 10 to the power minus 25 Newton meters. We need to find E. Let's see how to do this. Tau equals to P into capital E. Therefore, E equals tau by P. Since theta equals to 90 degrees. Therefore, 6 into 10 to the power minus 25 by 3 into 10 to the power minus 29. This in Newton meters and this in does 2 into 10 to the power Newton C to the power minus 1. In the second one, we need to calculate or see what is meant by drift speed of free electrons. Drift speed of free electrons means the average of minimum and maximum velocity of free electrons between configuration and consecutive collisions with positive ions. Let's see another question. Next, we are asked on which conservation principle is Kirchhoff's second law of electrical networks based? The answer is Kirchhoff's second law of electrical networks is based on velocity of electrons and mass transformation remains constant throughout the entire energy circle. That is also known as law of conservation of energy. In the fourth one, we are given that at the center of a circular coil of 50 turns having radius of 0.5 meters and 5 ampere, we have to calculate the magnetic flux density of this magnetic field. Let's write down the information that we are given. N equals to 50 turns. R equals to 0.5 meters, which is the radius. Current I equals to 5 amperes. Therefore, magnetic flux density, which is written as B, is equals to mu naught Ni by 2A. Now putting in the values, 4 pi into 10 to the power minus 7 into 50 into 5 by 2 into 0.5 into T. This equals to 2 pi into 10 to the power minus 7 into 500 T. Therefore, B equals to 3.14 into 10 to the power minus 4 T, or B equals to 10 to the power minus 4 pi Tesla. Moving on to the next question. An AC generator generates an EMF E where E equals to 314 sine 50 pi t volt. We need to calculate the frequency of the EMF E. Since E equals to 314 sine 50 pi t volts, therefore omega equals to 50 pi. Hence frequency F equals to 55 by 2 pi equals to 25 hertz or radian per second. Easy? With what type of source of light are cylindrical wave fronts associated with? 6 can be written as line source of light yields cylindrical wave fronts. Now we are given two very important questions. The first question is based on Young's double slit experiment. How is fringe width of an interference pattern in Young's double slit experiment affected if the two slits are brought close to each other? Let's see what the answer will be. Fringe width beta equals to lambda d by small d. Now if small d decreases, the value of beta, which is the fringe width, increased. Thus, if the two slits are brought close to each other, the interference pattern has the fringe width increased. Number 8. In a regular prism, what is the relation between angle of incidence and angle of emergence when it is the minimum deviation position? Angle of equals angle of emergence in the case of minimum deviation. This is the relation that is required in this question. Let's see what other questions we have. In the first one, we have a converging lens of focal length f equals to 40 cm, which is kept in contact with a diverging lens of f dash 30 cm. We need to find the focal length of the combination. Let's see how to do this. 1 by f dash, which is the focal length of the combination, equals to 1 by f1 plus f2. Here f1 is equals to 40 centimeters and f2 is equals to 30 centimeters. Now putting in the values, we have 1 by 40 minus 1 by 30, and upon calculation this comes to 1 by f dash equals to 3 minus 4 by 120 equals to minus 1 by 120 centimeters. Thus the focal length of the combination is a diverging one. In the next one, we are asked, how can the spherical aberration produced by a lens be minimized? Let's see. Spherical aberrations can be removed by covering the central part of the lens with an stop, which is actually an opaque object that is put in order for this purpose. Moving on to the other questions. In the first question, we need to calculate the momentum of a photon of energy 6 into 10 to the power minus 19 joules. Let's see how to do this. Energy of photon E equals to P into E. We are given the values of E and we know the value of small e. Therefore P equals to 6 into 10 to the power minus 19 by 3 into 10 to the power 8, which is equals to 2 into 10 to the power minus 27 Newton per second. Now in the next question we are asked, according to Bohr, angular momentum of an orbiting electron is quantized. What is meant by this system? The meaning is that the electron revolves around the nucleus in fixed, that is quantized orbits, and do not radiate any energy. In this, the angular momentum in these orbits is always an integral multiple of h by 2 pi, where h is the Planck's constant. Moving on to the final questions, we'll be dealing with 3 more questions. Why nuclear fusion reaction is also called thermonuclear reaction? I'm giving you the answer in just a second. This is because it takes place only at high temperature. High temperatures are required by the nuclei so that they will have sufficient energy to overcome the force that is known as the Coulombian force. Now in the next one, what is the minimum energy which a gamma ray photon must possess in order to produce an electron-positron pair? Let's see. This is called as pair production. Here V, energy, and mass particle reaction I have shown. Here energy is transferred into mass. As you can see, the minimum energy is known as binding energy, which is usually represented as Be, which equals 93 divided by MeV. Now in the last one, we need to show the variation of voltage with time for a digital signal. Since it is gonna be a diagram, I'll take some time and draw you the figure. This is how the figure will be. With this, we come to an end of another amazing video. Stay tuned, like, subscribe, and contact us for any doubts that you have. We'll be coming up with more such videos on physics and other subjects. Thank you.